So today we are going to do about how binary numbers are stored in memory and how you figure out the capacity. Okay. As we have seen in previous video, binary number consists of only 2 digits. So that already you have seen in the number system, binary number system video as well. You have only 2 numbers or 2 digits, 0 and 1 in the binary number system. A digit in the binary number system is known as binary digit. So this one or this one will be called a bit. Binary, BI, digit T. Okay, that's how they form the word bit. A view of memory bit locations. So just imagine the memory binary, the memory of the computer being something like this. So each of these location is a bit location, can have 0 or 1. Okay. Now although I have drawn this all blank, actually in the memory there can't be a blank state at all. Okay. Each of these locations will have either 0 or have 1 because these are binary locations, so it can't have a blank. Blank means a third state. These are two state devices, so it can only be either 0 or 1. Any other, it's not possible. Okay, so just remember that. So each square is a bit. That means it can have 0 or 1. Bit is the smallest storage location in memory. So that is the smallest. You can either, anyway you can save is 0 or 1, 0 or 1. And then you keep on doing that for each and every location. 0, 1 here, 0, 1 here, 0, 1 here, 0, 1 here. So that's it. But the smallest location is 1 bit that you can store. Each bit can either be 0 or 1. Say, can have 0 like that, or it can have a 1 like that. Okay, those are the only 2 allowed values. Then the processor is made in such a way that it cannot access 1 bit only at a time from memory. That is what that means is, now each of these are bits. Now the processor is wired, or it's done in such a way, the hardware is such that the processor has no access to only one of these. It can't take only this and read. It can't take only this and read. It can't take only this and read. Or any of 1 bit it cannot read. The processor is not allowed to read 1 bit only. Okay, that's what this means. So what is possible? The possible amount of bits, memory bits, the processor can access at a time is 8 bits. Okay, always 8 bits. So this 8 bits is known as 1 byte. Okay, look at that. So if the computer is going to access the memory, it has to read all this. So all the ones and zeros that are in these 8 bits will be read at once. It can't read only this or only this or only this. One at a time can't read. It has to read this. Or the computer is engineered in such a way that each read the processor can read will be a byte. Okay. See, 1 byte. So 1 byte is the smallest possible memory location that the processor can access at a time. Okay. But the actual smallest memory location is 1 bit. But 1 bit processor can't access. So it has to have a combination of 8 bits to access, which is 1 byte. Okay. So this is the smallest the processor can access. See, now these are all bits. Is 8 taken together is 1 byte. So the processor can access this whole thing only. That's the lowest it can access. It can't go to a bit and access only that or only this or only one of these. Any of one of these, it's not allowed. Okay, the processor is not wired or made like that to do that part of the job. It has to read this entire thing. So the processor always reads 1 byte at a time. A view of byte memory, that is the memory accessible to the processor. How does the processor takes? Because processor is now not taking 1 at a time, 1 bit at a time, it's taking 1 byte at a time. So let's look at how the memory will look. So I have split that earlier screen to small 8-bit sizes. These 8 bits here, 8 bits here, 8 bits here, because that is exactly what the processor can access, one here, one here, one here, like that. Okay, so let's see. This is 1 byte. 1, 2, 3, 4, 5, 6, 7, 8 bits are there. So this is what 1 byte is okay. 1 byte is one memory location as far as the processor is concerned. So when the processor accesses something like this, it will be accessing this whole thing. Then this is the second memory location. This will be the third memory location. Okay, this will be the fourth memory location. This will be the fifth memory location, sixth. Then 7th, 8th, 9th, 10th, 11th, 12th, 13th, it goes on like that. Okay. In actual, you can imagine the memory location to be just continuous like that. Now, I can't show it on the screen like that. No. So that's why I have written this one here, this one here, this one here, next one below. Otherwise, what will happen is 4 will also be here, 5 be, after that 6. It will be a huge stretch. Okay, just imagine like that. So it's a stretch, and from that only the processor can read each of the memory location. Now, once the memory location is identified as this, or the hardware has worked out this is one memory location, this is the next memory location, that's after, the bit after this starts the next memory location. The bit after this starts the next memory location. Okay, the computer can't go and read 3 bits from here and 4 bits from 5 bits from here and make it 8 bits and read like that. Okay, it's not allowed to read partial of here to make 1 byte. It's always at the beginning itself, when the memory is made, it's made like this. So this is memory location 1, this is memory location 2, this is memory location 3, right? So when the processor is reading, it can either read location 1 or location 2 or location 3 or location 4, 5, like that. Okay, it can't combine some part 4 bits from here, 4 bits from here and read that as another memory location. That is not allowed. Okay, it will only be able to read one memory like this, one memory, the continuous memory, the next one like that. Okay, at the end of the first byte, the next byte starts. At the end of the second byte, third byte starts. At the end of the third byte, fourth byte starts. At the end of the fourth byte, fifth byte starts. Like that, it will go on. So that is why a view of the memory, how the processor can access. Okay, now let's see about kilo. This we need to roughly understand to work with this binary storage. So let's go through that and see. Kilo means 1000, as you know. Okay, say 1000 grams is 1 kilogram. Okay, 1000 meters will be 1 kilometer. So like that, thousands of something is 1 kilo of that. We will see a parallel between decimal and number system, binary number systems, using the weight to get to 1000. We will understand, because binary numbers have a different 1000 really. So to understand why that 1000 goes like that, let's do a comparison between these two, decimal and binary number system. Okay, this is the and that actually happens through the weight. Okay, so now here we have the binary decimal number weight system. Here we have the binary number weight system. Okay, so let's start the decimal number, 1, then you multiply by 10 by base of numbers. Decimal number system is 10, right? So 10, 1 into 10, 10, again 10 into 10, 100, 100 into 10, 1000. Now there we reach 1000. So this is what kilo means in decimal number. So there is not an issue. In the weightage it came, no problem. If we go to the binary number system, we will start with 1, then we go to 2, then we go to 4, then we go to 8. Why? Because the base of binary number system is 2. 2 digits only it has. No? So base is 2. So you start from 1 and keep multiplying by 2 to get to the next value. Okay, and you continue like that. Then after 8 you will have 16, double, right? Multiply by 2 again. Multiply this by 2, 16. Then you multiply this by 2, 64. So multiply that by 2, 128. Why are we still going? Because we haven't still reached 1000, right? Multiply by this by 2, 256. Multiply this by 2, 512. Then multiply again, still not 1000, right? 512 multiplied by 2, 1024. There we reach 1000. So this is the 1000 in the binary number system, not this. In the decimal number system, I'm not talking about the 1000 exact value. 1000 exact value is there in binary number system also, but they don't use that as the kilo. What they use in the kilo is what comes in the weight, the closest value to the 1000. So the closest value to the 1000 in binary number system is 1024 in the weight system. So if you write the binary number 1024, what you will do is you will put 1 here and all the rest will be zeros. Similar to 1000 here, 1 and rest are zeros. So 1 and rest are zeros. So this 1 is not this 1000. It's not the normal 1000 we are used to. It's actually 1024. This is the reason why kilo in binary number system is 1024 and not 1000. So remember that. It will be helpful in the next slide. So now we will see how the memory storage unit works. As we know, one binary digit is either 0 or 1. Binary number has only 2 digits, so 0 or 1 is called binary bit or binary digit, 1 bit. 4 bits are equal to, when you group 4 bits, it's called a nibble. This is not very important for us, but why I put that is because if you are reading online or somewhere, if you come across this word nibble, that means it's just 4 bits. 4 bits grouped together is called a nibble. Now, but this is the most important. Why? Because processor reads 8 bits at a time. So this 8 bits is called a 1 byte. So in reality, what the processor is reading from memory is 1 byte at a time. Okay. So 1024 bytes is called 1 kilobyte. See, 1024 bytes because of the previous slide. I showed you how binary works. 1000 is like, or what it considers as close to 1000 is 1024. That is why 1024 bytes is 1 kilobyte, not 1000 bytes. They don't use 1000 bytes, they use 1024 bytes to indicate 1 kilobyte because of that weightage reason. Okay. So then again, 1024 bytes of kilobytes. 1024 of kilobytes is what is called 1 megabyte, MB. Okay. And further, if you go, 1024 megabytes will be 1 gigabyte or gigabyte or whatever you want to pronounce it. Then 1024 gigabytes is called 1 terabyte, TB. This also we are now very familiar with the hard disk capacities of 1 TB and 2 TBs and 4 TBs and so on. Okay. Then next one, 1024 of terabytes is considered 1 petabyte, PB. And there are some more things, but I thought I will not go through that. If you want, you can go through the Google it, or I don't know, somewhere on the online you can find out. So this is actually 1 petabyte. What does this mean? What this means is this is how you measure the storage space in the memory or in the hard disk or whatever. So just remember, when you say 1 kilobytes, we are talking about 1024 bytes. So when you are talking about 1 megabyte, we are talking about 1024 into 1024 bytes is what megabytes will be. And that into 1024 will be the gigabytes. So many bytes, so many accessible memory units for the processor. Okay, so that is what is very important to understand from this lesson. Okay, so that brings us to the end of this, and we will meet again in the next lesson. Thank you very much.